Welcome to the module 2 in the subject computer organization. Module 2 name input output organization. By studying this, students the course outcome can be the course outcome is to demonstrate functioning of different subsystems such as processor, IO and the memory. Here we focused only on IO. The same course outcome is used in the other module also. Let us start with the contents. How to access IO devices and connection for IO devices, mechanisms used for interfacing IO devices. Interfacing in the sense how to connect IO devices, what are the different mechanisms. Accessing IO devices. Multiple input output devices may be connected to the processor and the memory via a system bus. A bus consists of three sets of lines in order to carry the address, data and control lines. Bus is a group of lines. Each IO device is assigned a unique address. So if at all it has to distinguish one IO device from the other, it should have a unique address. To access an IO device, the processor places the address on the address lines. The device recognizes the address and responds to the control signals. IO devices and the memory may share the same address space. This happens in the memory mapped IO. It uses the instructions which also stores in the memory. Any machine instruction that can access memory can be used to transfer data to or from IO device. It is simpler software. IO devices and the memory may have different address spaces as it is in the program control IO. Special instructions to transfer data to and from IO devices. IO devices may have to deal with fewer address lines. Why is it? Because the same in the memory mapped IO, the IO devices and the normal programs, everything uses the same address, means the number of bits or the address lines will be more. But if it has a different address space which is pertaining to the IO device, obviously the number of lines used for these IO devices, address lines will be very less. Think of analogy that if the chapters are less, then the page number also will be less. Another analogy, if the number of users or the number of registrations in the university, if less, then it will have very less number of digits in the USN. If it has more number of digits, more number of registrations, then it will have so many number of digits in the student registration. IO address lines need to be physically separate from the memory address lines in the this type of addressing. In fact, address lines may be shared between IO devices and memory with a control signal to indicate whether it is a memory address or an IO address. With the same line, with the same signal, it can be used to represent it's a memory or a IO address. IO devices is connected to the bus using an IO interface. You can see the IO interface which is in the pink in color. It comprises of address decoder. The interface consists of address decoder, control circuits, data and status registers. Address decoder decodes the address placed on the address lines. Say processor is sending the address, IO device address, that will be decoded by this address decoder and enable that specific device to recognize its address. Data register holds the data being transferred to or from the processor. That's why it is two-way. And the control, the status register holds the information necessary for the operation of the input output device. The data and the status registers are connected to the data lines and have unique addresses. The I/O interface circuit coordinates I/O transfers. I/O interface, with the help of I/O interface, you can easily coordinate. Say for an example, when you have a USB port in the computer, you can easily plug in the USB and then you can start plug and play. That means you can start using it. That because that supporting socket is nothing but I/O interface. Similarly, is any other device, if you want to connect, if the supporting interface is there, you can easily use it, like webcam or anything. Okay, the connection for I/O devices. The interconnection network consists of, here, let's suppose keyboard and display are connected to the network, and then via the processor it is connected using the interconnection network. Mechanism used for interfacing I/O devices. The need for mechanism is to synchronize data transfers between them. How it can be done between them? Using the program control I/O. Processor repeatedly monitors the status flag to achieve the necessary synchronization. This already discussed in the module 1. The processor will keep on checking the SIN flag, SOUT flag, SIN flag in order to see whether the input data is ready, SOUT flag in order to check whether the display is ready to receive the output. So here processor keeps on polling the I/O devices. Poll means here it is keep on checking the status register of the I/O device. Two other mechanisms used for synchronizing the data transfer between processor and memory is interrupts and DMA. This is the end of the session 1 in the module 2. Thank you.